At the start of the war in Ukraine, Russia's Aerospace Forces, or VKS, fielded roughly 780 tactical combat aircraft, compared to Ukraine's roughly 125. That was still a 5-to-1 advantage in raw numbers, backed by what was supposed to be one of the world's most formidable air forces. Fast forward to late 2025, and not only did Russia fail to achieve air superiority over Ukraine in the war's opening weeks, but both its military and civilian aviation industries are now careening toward what experts are calling an inevitable collapse. And according to recent analyses, that collapse could become undeniable as early as 2026. This isn't hyperbole or wishful thinking. Multiple independent assessments from military think tanks, intelligence agencies, and industry analysts point to the same alarming conclusion. Russia is systematically running out of aircraft, the capability to produce new ones, and even the skilled workers needed to keep existing planes in the air. So let's examine exactly how Russia went from supposed aerial supremacy to potential aviation catastrophe in less than 4 years. In November 2025, the Royal United Services Institute published a comprehensive analysis that sent shockwaves through defense circles, titled "Vulnerabilities in Sukhoi Production, Clipping Russia's Wings." The report laid bare just how fragile Russia's military aircraft manufacturing has become. Starting with the pure numbers, Russia produced just 9 Su-34 fighter bombers in 2022, then 13 in 2023, and had a target of only 17 for 2025. With regard to the Su-35S air superiority fighters, Russia ordered 12 aircraft in 2024, but managed to deliver only 10. The 2025 target is 16 Su-35s, but deliveries have been unevenly distributed, suggesting significant delays. Putting that in perspective, open source intelligence Oryx has confirmed the destruction of 41 Su-34Ms and up to 8 Su-35s visually until October 2025. Rand Corporation's 2024 assessment found that Russia was effectively losing 26 aircraft per year from overuse alone. Meanwhile, Russia currently procures only about 20 Su-30, Su-34 and Su-35 aircraft total per year combined. So the country is barely replacing what it's losing, let alone expanding its fleet. But the real crisis is in what's causing the lower production numbers. The RUSI report reveals that Russia's aircraft manufacturing depends heavily on foreign components, machine tools, and specialized equipment scattered across a complex supply chain. In general, Sukhoi production depends on imports from Germany, France, Japan, Taiwan, Italy, Sweden, South Korea, and the United States. Take the example of the Karachevsky Zavod Electro Detail, or KZE, which is a critical node in Russia's supply chain that produces precision parts and components for the electronics industry. A single Karachev-based plant delivers its high-accuracy components to over half of Russia's major military industrial manufacturers, including aviation, air defense, and missile manufacturers such as Almaz Antey and OAC itself. The factory floor is filled with exquisite Japanese-made SODIC electrical discharge machining tools. But Japan banned the export of all CNC machines to Russia in April 2023. And expanded these restrictions in February 2024. The SODIC machines at KZE guarantee accuracy for only 10 years, and they received the equipment in 2017. That means within the next couple of years, these critical machines will need replacement parts or complete replacement, which Russia can no longer legally obtain. Then there's the brain drain. The median age of military manufacturing employees in Russia was 45 years in 2021, with only 16% under 29. Take Professor Yuri Yukhanov of South Federal University, who's a leading scholar in antenna and radio transmitting devices at 73 years old, and works closely with OAC and Sukhoi's R&D arm. His son, Alexander, completed his PhD in radio engineering and software at the same university, and then promptly emigrated to the United States in 2007, where he now works as a principal software engineer at Meta. This pattern repeats across Russia's aerospace sector. The bulk of the talent is the old Soviet Guard, who studied at top universities and leveraged the country's booming industry to gain long-term employment. But young, talented engineers see the writing on the wall. The average Russian university professor makes only about $1,302 per month, with some sources nuking the average and ranking it behind neighbouring Kazakhstan in terms of purchasing power parity, let alone Western institutions. Meanwhile, Russian defense industry workers face shortages ranging from 160,000 to 400,000 workers and engineers, with the most conservative estimates suggesting 80,000 engineers are needed just to maintain current production levels. Perhaps most damning, the RUSI report notes that Russia has struggled with import substitution in the aviation sector. Despite government initiatives to replace Western components with domestic alternatives, the results have been mixed at best. In many critical areas, Russia's dependence on foreign-made systems is actually increasing rather than declining. While Russia's military aviation struggles, its civilian aircraft industry faces an even more spectacular implosion. In 2022, shortly after launching its invasion, the Russian government boldly proclaimed it would procure more than 1,000 new civil aircraft for airlines by 2030. The plan included producing 14 aircraft by the end of 2022, 25 in 2023, and 69 in 2024. But over the 3 years of war, Russian factories have produced only 5 civilian aircraft. Not 5 per year, 5 total. By 2025, Russia had delivered just 1 commercial aircraft out of 15 planned. Production targets were slashed from 171 aircraft for 2024-2025 to merely 21 units, and even those revised targets are being cut again due to financing challenges. The situation became so dire that in 2025, the government reduced spending on aircraft production due to ongoing delays and manufacturing challenges. The reason for this is quite simple, as sanctions have essentially strangled the industry. Russia's civilian fleet consists of over 700 aircraft, predominantly Airbus and Boeing models. With Western sanctions blocking access to foreign-made aircraft and spare parts since 2022, Russian airlines now depend on complex, indirect grey market import routes to source critical components. The consequences are already visible in the skies, or rather, increasingly on the ground. Up to 30 airlines stated in late 2024 that they would be facing potential bankruptcy in 2025, representing approximately 26% of Russia's passenger transportation. That's a quarter of the fleet grounded, with the rest needing to take up the slack. And the other companies aren't much better off, as the Russian government is constantly trying to increase company taxes to bulk up its budget. Small businesses are the latest in line, and it's only a matter of time until we see the big sharks get taxed just a bit more to compensate again. The production problems mirrored those in the military sector. Even when Russia attempts to build domestically produced aircraft like the Superjet 100, they rely heavily on Western components, most notably the Franco-Russian power jet SAM-146 engines and key avionics modules. Experts now warn that without access to new Western parts, the Superjet fleet is still facing mounting reliability issues. However, Russia has recently extended the service life of the SAM-146 engines, allowing the aircraft to remain in service until roughly 2028-2029, while Moscow evaluates a possible re-engineing with the PD-8. First, both sectors are subsidiaries of the same government-controlled corporation. The United Aircraft Corporation, or OAC, oversees production of everything from Su-35 fighters to two Tu-140 airliners, from IL-76 military transports to MC-21 commercial jets. When OAC announced it wanted to boost Sukhoi fighter jet production by 30%, it simultaneously announced plans to fire 1,500 management staff. So it was essentially transferring management and budgets from one bucket to another. Second, they cannibalize each other for parts and supply chains, both inside Russia and internationally. The spare parts, maintenance facilities, and technologies that go into planes aren't neatly divided between military and civilian. Russian industry has been caught using parts intended for civilian aircraft to keep military jets flying and vice versa. The The machine tools at KZE that we mentioned earlier, they produce components for both military avionics and civilian flight systems. When those tools break down or need replacement, the shortage cascades through both. Third, when factories shut down or lack resources, other facilities must be retrofitted to produce both civilian and military aircraft parts simultaneously. This puts enormous strain on already limited resources. A metallurgy plant can't easily switch between producing titanium alloys for Su-35 airframes and commercial airliner components, but increasingly that's exactly what Russia is demanding. And when the Russian government demands a contract, it either gets the contract or the management faces criminal charges and jail time for failing to meet it. But there's also another theory. The Russian government is deliberately implementing a strategy of periodic sacrifice, reducing productivity in one industry to prop up the other, then reversing course months later. The logic is simple. Russia needs civilian aviation to maintain internal connectivity across its vast territory and to project an image of normalcy to its population. It also needs military aviation to continue the war in Ukraine and maintain its strategic deterrent. When resources become too scarce to maintain both adequately, Russian planners apparently believe they can juggle priorities, boosting military production for a critical offensive a year down the line, then pivoting back to civilian production when domestic air travel becomes too dysfunctional. But this approach is failing on both fronts. There simply isn't enough money to fuel both industries when neither is actually making any money themselves. Consider the workforce crisis. The United Engine Corporation's ODK UMPO plant in Ufa produces engines for Sukhoi military aircraft. But the same region's universities and technical schools also train engineers for civilian aviation. When young engineers emigrate to flee conscription, both sectors suffer. When the military offers inflated salaries to lure workers from civilian manufacturers, it's just redistributing a shrinking pool of talent. The Aviastar aircraft plant in Ulyanovsk similarly faced a workforce deficit of 2,500 workers in January 2024. By April 2024, that deficit had grown to 3,500. This plant produces both military transport aircraft and participates in civilian aviation projects. With the production crippled, Russia needs to be careful on how it's using the existing fleet, which is where the problems only start piling on. Russian military aviation doctrine, as outlined in reports from the French Institute for International Relations, never envisioned widespread sustained air dominance operations. Russian aircraft are primarily designed to deter incursions, provide close air support to mechanized infantry, and target vital enemy positions to soften them before ground assaults. This doctrine worked reasonably well for brief conflicts in Georgia, Crimea, and Syria. But Ukraine is different. The war has continued far longer than Russian planners predicted, and these aircraft are accumulating dangerous flight hours. As the RAND Corporation reported in March 2024, the Russian Air Force was flying at less than 75% of its pre-war capacity. Initially, Russian forces flew over 150 sorties per day, pushing older aircraft to their operational limits. This is the imputed loss problem. When an aircraft is designed for a certain number of flight hours over its lifetime, exceeding those hours dramatically increases failure risk and reduces future operational availability. The majority of VKS fighters operating over Ukraine are the newer Su-30, Su-34 and Su-35 aircraft. But according to RAND, slightly more than half of VKS's tactical airframes overall are more than 30 years old, largely older Su-27s, MiG-29s and early Su-30 variants, with far fewer flight hours left in their service lives. The older MiG-31s and Su-27s have been relegated to supporting strikes and performing only air patrol at a distance. With an estimated average remaining airframe life of less than 20% and 35% respectively, these older aircraft simply don't have enough hours left for sustained combat operations. Russia's air-to-air MiG-29s are totally absent from the conflict, even from air patrol missions. Given their age, these aircraft are either unserviceable or are being kept in reserve for some hypothetical final mission. Either way, they're effectively useless. Russia's response to this crisis has been to radically transform how it uses aircraft. Enter the glide bomb revolution. Starting in 2023, Russia began mass-producing UMPK glide bomb kits, essentially guidance and wing modules that convert old gravity bombs into precision-guided standoff munitions. These bombs, ranging from Fab 500 to the massive Fab 3000, can glide up to 40 miles after being released, allowing Russian aircraft to attack from well behind their own air defense umbrella. The strategy worked brilliantly from Russia's perspective. Instead of exposing jets to Ukrainian air defenses at close range, Russian pilots could now launch glide bombs from standoff distances and immediately turn back to safety. This dramatically reduced aircraft losses while maintaining or even increasing their destructive firepower against Ukrainian positions. Russia dropped over 5,000 glide bombs in April 2025, 3,786 in July, and 4,390 in August. Production of UMPK kits rose from several thousand in 2023 to 40,000 in 2024, with a target of 70,000 for 2025. But here's the critical point. While glide bombs reduce exposure to air defenses, they don't reduce flight hours. Every sortie still requires takeoff, transit to the launch zone, weapons release, and return to base. The aircraft still accumulate some wear and tear. Russia has essentially created a tactical adaptation that masks but doesn't solve the strategic problem of airframe exhaustion. It's flying marginally safer missions, but still running out of planes. Ukraine has also identified a potentially decisive vulnerability in Russia's aviation-dependent strategy: the glide bomb production infrastructure. While Russian jets can deliver these weapons from relative safety, the UMPK guidance kits themselves require specialized manufacturing. The Kometa series of jam-resistant GNSS navigation modules, produced by VN-IIR Progress with plants in Cheboksary and Moscow, are critical components installed in both the Shahed drones flying daily toward Ukraine and the glide bombs decimating Ukrainian defensive positions. Moscow-based GNPP region manufactures most of the glide bombs used by Sukhoi jets. These facilities depend on the precision components from companies like KZE that we discussed earlier. The supply chain, while distributed, has identifiable choke points. Ukraine has demonstrated increasing capability to strike deep into Russian territory. Operation Spiderweb in June 2025 reportedly damaged or destroyed 41 military aircraft at the Kazan aviation plant in a series of daring drone attacks. These long-range strikes have evolved from experimental nuisance raids to systematic targeting of Russia's military-industrial complex. If Ukraine can sustain strikes against glide bomb production facilities, the effects would cascade throughout Russia's air campaign. With Russia dropping over 5,000 glide bombs monthly, even a 30 to 40% reduction in production would significantly degrade Russian offensive capabilities in critical sectors like Pokrovsk, which sees up to 450 glide bombs per week. But there's a dilemma for Ukraine. Every drone aimed at glide bomb factories is a drone not aimed at oil refineries. Ukraine's campaign against Russian oil infrastructure has disabled 20% of Russian refining capacity, reduced output, forced a VAT hike, and driven Moscow to rapidly redistribute social programs toward military-industrial complexes. Russian economist Vladislav Inozemtsev described oil strikes as the most efficient thing Ukraine can do to hurt Russia's war machine. But glide bombs are killing Ukrainian soldiers right now. They're flattening defensive positions that took months to construct. They're forcing Ukrainian units into open fields where they become easier targets. As analysts Nikolai Staikov and Jack Watling wrote in their Rusi report, because of the number of precision subcomponents necessary to assemble fighter aircraft, even minor delays and disruption to production have a significant knock-on impact in suppressing the acceleration of aircraft production. This principle applies equally to glide bomb production. A few successful strikes on the right factories could create bottlenecks that take months to resolve. These are months during which Ukrainian defenses could stabilize, counterattack, and reshape the battlefield dynamic. The trade-off is clear but agonizing. Striking glide bomb production might save lives and positions in 2025 and 2026, but continuing to strike oil refineries might collapse Russia's economy and force an end to the war by 2027. Every strategic decision requires choosing between short-term tactical relief and long-term strategic victory. But Ukraine is far from the only external force that can push Russia's air force to the brink of collapse. For decades, Russia was a significant force in global arms exports, particularly in combat aircraft aimed at the former Soviet states and the Third World. Russian jets offered a compelling value proposition, reasonably capable platforms at a fraction of Western prices, with relatively simple maintenance requirements. Countries from India to Algeria, from Egypt to Vietnam, built their air forces around Russian designs. But China has emerged as the decisive threat to Russia's aerospace export dominance. The People's Liberation Army Air Force once depended on Russian aircraft. In the 1990s and early 2000s, China procured multiple batches of Su-30M KK fighters. They struggled to develop their own jet engines and were eager customers for Russian technology. Today, China produces the J-20 stealth fighter, a fifth-generation aircraft that is significantly more capable than Russia's Su-57. China's aerospace industry has not only caught up to Russia in many areas, it's surpassed it. Export-wise, China now offers what Russia once did: capable aircraft at competitive prices. It's sending out fourth-generation aircraft to foreign customers, with the J-10 already exported to Pakistan and several other countries, such as Egypt, Iran and Indonesia, reportedly evaluating Chinese fighters as potential future purchases. The fifth-generation J-20 and its successor, the J-35, are also approaching serial production, with the J-35 being particularly notable as a potential Western analogue and a clear step beyond Russia's aging designs. The war in Ukraine has also accelerated this shift by exposing the weaknesses of Russian equipment in real combat conditions. Countries watching Ukrainian drones systematically destroy Russian tanks and shoot down Russian aircraft are drawing obvious conclusions about the vulnerability of Russian military hardware. India, historically one of Russia's largest arms customers, made a pointed decision when selecting new fighters. After observing the performance gap between Russian and Western systems, New Delhi chose the French Rafale over the Russian Su-57s. Egypt, which operates both Rafale and Su-35 aircraft, concluded through competitive testing that the French fighter is significantly more capable. Even more damaging, India is now cautiously considering creating a stealth fighter in response to the Chinese J-10 entering Pakistan and Russia's exports flatlining. That second point is supported by the Jamestown Foundation, which stated that Russia's arms exports collapsed by 92% from 2021 to 2024. Moscow has redirected virtually all production to its own military needs, since it's unable to simultaneously sustain the Ukraine war and meet export commitments. The few countries still interested in Russian aircraft face a sobering reality. Russia cannot guarantee delivery timelines, spare parts availability, or sustained support. The Su-57, Russia's showcase fifth-generation fighter, has barely been deployed even in Ukraine. Export customers for this aircraft have largely evaporated. Iran, desperate to replace its aging pre-revolution fleet, has been eager to obtain Su-35s as part of its burgeoning defense cooperation with Russia. And while Iran reportedly received its first Su-35 SE airframes in late 2024, Russia has struggled to deliver the broader fleet Iran expected. Following Israel's Operation Rising Lion, which showed that Russian S-300 air defense systems could be completely overwhelmed, Iran also began exploring Chinese air defense alternatives to fill the gaps Moscow couldn't. The long-term implications are also problematic. Several countries across Africa and Southeast Asia operate Soviet-era aircraft that are reaching the end of their service lives. Many face elevated threat environments and need to modernize. Russia was once the obvious supplier for these nations. Now, they face a choice between Chinese aircraft or somehow finding the budget for more expensive Western alternatives. For Russia, losing these export markets isn't just about immediate revenue. Export earnings historically funded research and development for next-generation systems. Without export income, Russia's ability to innovate and compete technologically will further deteriorate. It's a feedback loop. Poor performance leads to lost customers. Lost customers mean less R&D funding, and less R&D means even worse performance in the next generation of aircraft. When you step back and look at the totality of Russia's aviation crisis, what emerges is a picture of multiple, mutually reinforcing failures converging toward a critical breaking point. The International Institute for Strategic Studies previously delivered a devastating assessment that Russia will run out of tanks to fuel its operations by 2026. But that assessment could very well apply to aircraft and is possibly even more damning. Unlike tanks, where there are tens of thousands of Soviet-era units in storage depots that need to be minimally refurbished, aircraft require precision maintenance, regular inspections, and replacement of time-limited components. You can't just drag a 40-year-old MiG out of a warehouse and expect it to fly combat missions. If Ukraine can maintain and expand its deep strike campaign, Russia has a few options in 2026. Option 1. Continue trying to sustain both military and civilian aviation at reduced capacity, watching both sectors steadily deteriorate until catastrophic failures force wholesale grounding of fleets. Option 2. Abandon civilian aviation entirely, cannibalizing every possible resource to keep military aircraft flying for the war effort. This would leave Russia's vast territory without adequate internal air connectivity and signal economic disaster to the population. Option 3. Abandon military aviation expansion, focus on preserving a minimal deterrent force, and try to rebuild civilian aviation before the entire industry implodes. This would essentially concede the ability to continue offensive operations in Ukraine. All of these are variations of strategic defeat. The most likely outcome is that Russia doesn't consciously choose any single option, but instead drifts between all three, making ad hoc decisions as crisis conditions dictate. The result would be a slow-motion collapse playing out across 2026 and beyond, with mass flight cancellations, aircraft grounded en masse for lack of parts, production lines going idle for weeks or months, and steadily declining sortie rates in Ukraine. Thanks for watching. Now, to understand how Ukraine has managed to systematically degrade Russia's military capabilities across multiple domains, check out this video. And to stay informed about the daily evolution of the war and its implications for global security, subscribe to The Military Show.